Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. Let's decode this SMD capacitor. These are used in the output stage of this power supply. 3 capacitors in parallel. Let's suppose these capacitors are damaged, short circuit. In my last video, I shared method to decode this capacitor 1210. Whatever I share on my channel, that is my experience, that is my opinion, that is my method. How do I understand things? I share with my viewers. Might be you will agree with this, might be you will not. I share only what I see with theory and practical. These capacitors are good. Let's suppose these capacitors are short circuited, damaged. If it is burned out, its body size is damaged. That time it is difficult to decode it by measurement system. Basically these all circuits which are now SMD, these are not repairable. Manufacturers are manufacturing it for power saving. When it is damaged, throw it away, no repair. We can repair that circuit in only one way: when we have its circuit diagram, when we have its service manual. That time we can take approach to replace the component. Otherwise, using reverse engineering method, we will shortlist different selected components within that parameters. Sometimes we will find exactly that components, or sometimes we will find 3, 4, 5, 6 components. We can select one by one using that value. Basically capacitance and voltage are our requirement. 1 microfarad 16 volt, 1 microfarad 25 volt, 10 microfarad 50 volt, whatsoever. We need capacitance and voltage. If we shortlist 3 or 4 components out of 50,000 components, we can use that value components to test our circuit. If it is working good, then we can use a normal capacitor, or we can select the exact SMD capacitor. Let's start. If I want to take measurement for this component in this condition, I will not take exact measurements. We will take measurement in inches and millimeter. There is huge amount of solder. It is measuring 3/4 in inches, 134, 135. It is important to clean it, to clear the terminals. If there is any deposit, if there is any solder, if there is any rust, that time we cannot take the exact measurement, and the measurement is basic key point to decode these components. Because there is epoxy in the bottom, now we will take measurements in inches and in millimeter. 3.21, length 3.21, 0.126, 3.21 millimeter, 0.126 inches. This is length. .61 millimeter. 1.61 millimeter. In inches, 0.064 inch. 0.064 inch. These are two measurements, length and width. Now the next we need to check the circuit where it is being used. If the same capacitor is being used with this microprocessor, working voltage of microprocessor are just only 5 volt. There are no heavy spikes on that capacitor. It will just only remove switching noises of that microprocessor. That time we need a limited spare headroom for that capacitor. If it is 5 volt multiply with 110% to take the working voltage of that capacitor. That time we need accuracy, tolerance, 1%, 5% tolerance. But if same size code is being used in this power supply at output stage, working voltage of this power supply at that stage, nominal voltage 24 volt, 21 volt minimum, maximum 29 volt, 30 volt. We will consider this rating. This capacitor will deal with load because it is connected exactly at output terminal. There will be load transitions, ripples. 29, we will take 130% to 150% of this range to determine the working voltage of that capacitor. Let's suppose 29 volt. Multiply with 1.3. It is 37.7 volt. And if you make it more safe, 29 multiply with 1.5, that is 43.5 volt. That means we need a capacitor with this working window. Normal ranges for 6.3, 10 volt, 16, 25, 35, 50 volt. This capacitor will fall in this range, maybe 35, maybe 50. We will select these two voltage values now. Now we have working voltage and these case codes. From length 3.2, we will not write point, we will write 3, 2, and from this code 1.6, we will not write point, we will select 1.6, and this 0.12, we will select 1, 2, after dot 0.6, we will write 0.6. 1206 capacitor in inch code, 3216 millimeter code with this voltage. 1206 MLCC 50 volt capacitor datasheet. Let's check this one. Open it. We can check formula, we can check RS components. Now we have this table, 1206 50 volt multilayer ceramic capacitor. From this table now, manufacturer we don't know, capacitance we don't know, dielectric we don't know. We know the size code. Then it is SMD. Termination we don't know. Minimum operating temperature, because it is working in power supply minus 55 degrees Celsius to 125. That is normally used capacitors in the power supplies. If it is polarized, that time 105 degrees Celsius. in ceramic MLCC minus 55 to 125 degrees Celsius. Length 3.2, width 1.6 and height. Now we will measure height. Height or thickness is 1.15. Thickness 1.15. If it is 1.1, that will give another result. If it is 1.2, that time we will find another result. We need an accurate measurement by cleaning the terminals of the capacitor. Which product we are using? Automotive, general, high reliability. We will not select anyone. Series we don't know. Let's apply filter. The first result here, 1 microfarad 50 volt 5% with X7R dielectric AECQ 200 qualified, 5% tolerance, minus 55 to 125 degrees Celsius, 3.2 millimeter length, 1.6 width, 1.15 height, automotive grade. First capacitor, second capacitor, 0.043 50 volt 5% 1206 NP0 dielectric. And if you see its measurements, the same measurement 3.2, 3.2, 1.6, 1.6, 1.15, 1.15, same thing, just only the difference is dielectric. Here X7R and here is NP0 with the same dielectric. X7R we have 0.1 microfarad 50 volt from the same manufacturer. .2, 3.2, 1.6, all measurements, all parameters are same dielectric. With the first one we have 1 microfarad, we have 0.1 microfarad. With the same X7R we have 0.47, 0.1, 0.47 and 1 microfarad. 100 nano, 470 nano and 1000 nano. 3 capacitors with same dielectric, with same dimensions. Now we will check this capacitor value. Now we have 3 different values: 100 nano, 470 nano and 1000 nano. 0.1 micro, 0.47 micro and 1 micro. It is 1.047, 1 microfarad. So our capacitor is 1 microfarad 50 volts. Now we shortlisted 1 microfarad with same dielectric, 0.1 microfarad, 0.47. We can use 0.1 microfarad and we can check the results. If there are ripples, we will use 0.47 or we can use 1 microfarad. We will use simple capacitors and we will install it here. We will check the result. If 1 microfarad is giving good result, we will use 1 microfarad. If 0.47 is giving good result, we can use that one. Now it needs a try. I hope this video is informative. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.